go. So this week we're continuing where we left off at the end of last week's lecture. Hopefully we'll be able to finish at least the initial part of chapter 3. And the plan is to finish chapter 3 entirely by next week. Got way too many tabs open this week. So last week we started covering the application lifecycle. So we discussed requirements analysis, which members of a team might do requirements or participate in requirements analysis. We discussed design, these ideas of architectures, planning, modeling, what they all mean. We sort of briefly touched on development, although that's what we've been doing for the entire course, basically. So we just discussed the different kinds of developers there are. And this, you can see that as well on page 67 of your textbook. They've got the sort of the 4 participants that you guys need to know that participate in the development stage of the application lifecycle. And sort of where we left off last week is going more in depth into testing. So that's where we'll pick up this week. So we discussed these 2 different kinds of approaches to testing. There was black box testing, where you don't know about how the application is functioning. You just know the application, the system is a black box to you. It just has an input and an output. And then the other kind of testing where you know the code and you use your knowledge of the code to exploit the errors that occur within it. Okay. But I don't really like this distinction of testing. I think it's very vague and somewhat weird, difficult to understand. I prefer this more in-depth version called the levels of testing. This is the way that I like designating testing, and also I think the more useful, realistic one. Let me just open up the chat so I can see if when you guys are asking questions. So there are 5 levels of testing, and you can see them almost as scaling upwards. Oh, I thought of like creating a nice diagram for this. I'll do it and maybe show it to you guys next week. But yeah, so it almost scales up. It's quite a cool way of thinking about testing. So we'll start at the sort of smallest, finest scale of testing, then move upwards. And it's almost like you go upwards and outwards, but we'll discuss. So the first level of testing, the smallest or finest level of testing, is called unit testing. And I mean, you guys know what a unit is probably from some math class that you've taken before. We can just say define units. An individual thing or person regarded as single and complete, but which can also form an individual component of a larger, more complex whole. So that second bit is more, I think, applicable to us. An individual component of a larger, more complex whole. Okay, so unit testing is testing individual units of code, what we might call a method, a function, an algorithm, a procedure. Those specific units of code is what a unit test would be testing, okay? So like a single method, a single function, a single algorithm is what we might write unit tests for. This one is pretty easy to demonstrate like in our current context. So I'll actually show you guys a simple unit test and hopefully that can wake us up a little bit today. A nice example of a unit test might be a thing that debits someone's bank balance. Okay, so I'm gonna just write a unit test inside the main method over here. In order to do it, we need to actually create a thing that we can test, right? So I'll create a basic structure. So public class bank account, something like that. Okay, public class bank account. Our bank accounts, let's say, are just gonna have one really simple property. You can imagine that it would have a lot of other things like a username, an account number, all of that kind of thing. But we're just going to keep it super simple, and all our bank account class is going to have is just a balance, okay, a bank balance. Guys, just to wake us up, what level of encapsulation do you think someone's bank balance should have? So if we're discussing the encapsulation, what word am I going to use when I declare the property? Right, we have a couple of options here. We could call it public, private, protected. Yeah, I suppose so protected or private would probably work for us. I don't think we're going to be doing much inheritance though, right? So I don't think we're going to do much inheritance. So I think let's stick with private. Yeah. But yeah, both could work. Both could work. But yeah, since we won't be doing inheritance. And then guys, what type would someone's bank balance have? What type would it have? An int, perhaps? I mean, we can store cents though, hey? We could store cents. Yeah, exactly. I think let's go with a private double. That makes sense to me. So private double balance, I'll call it. And then I'm just going to auto implement the getters and setters. Okay. Now, because we're doing it this way with the get set, this word is, no, it's fine. Cool. Let's stick with this. Okay. Awesome. I am just going to, for the sake of the example, I'm going to change it to public. Okay. But remember, if you didn't want it to be settable from outside the class, we would remove the set over here. So it would just be get. Okay, something like that. But we'll go through and experiment a little bit. Ooh, whoops. We'll go through and experiment a little bit. Why is it not allowing me to close this? What is going on? And my computer is freezing, it seems. Oh my gosh. What is going on here? Google Chrome, geesh. This is so annoying. Hold on, guys. I think I need to stop sharing and try to close this somehow. What is going on? Okay, sorry, it took a while. I'm not sure why it did that. I see another person's joined us. Welcome. You joined us when we were having some trouble. Anyway, sorry about that, guys. We're back on track now. So I'm just gonna, we'll experiment a little bit with the types and stuff. Cool, but just to keep things simple, so I'm gonna create a constructor quickly. So I'm just gonna say public bank accounts. Okay. And it's just going to take in a double called balance, and it's just going to set the balance to balance. Okay, so whatever you give it, it'll set the balance to. Okay, so I think let's start by using that. So I'm going to create a bank account. I'll say bank account. Who was the last person who posted in chat? It was Chris. So this is going to be Chris's account. Bank account Chris equals new bank account. And we'll give it a double. Let's see. We'll say got 10,000 Rand in the account. Okay, that seems reasonable. Again, great. All right. The next thing is to just check. So I'll say console.writeLine, console.writeLine. And I'll just say account balance is Chris.balance, something like that. And hopefully that should work smoothly. Let me just try it out. Yeah, cool. That works nicely, and you won't be able to set balance from outside the class, which is quite cool. So you can set the initial balance, but you can't set balance from outside the class. Why? Because it has no setter. So if I tried to say Chris.balance equals 5,000 or something like that, and I tried to run this, it'll give me an error. It'll say bank account dot balance cannot be assigned because it is read only. Okay, why? Because it has no setter. You guys remember the whole getter and setter thing. Okay, so this is specifying how public the getter is. All right, just to clarify that for everyone. Okay. But yeah, you're correct. If we were creating a separate field, it would be private. Now, cool. So what we want to do is have something to test. Okay, the reason why we're setting up this silly little example is just to have something to test. So we're going to try write up a method that debits the account. Okay, that debits the account. So we'll say, we'll just create a simple method. For now, we're going to say it's public. Okay, obviously we would have to go more in depth on that. It's not going to return anything, and it's just called debit accounts. Okay, that's the name of the method, debit accounts. And what it does, it takes in a number that you want to withdraw. So we'll call that the withdrawal amounts. I'll call it with amounts, okay, or just amounts. Okay, I'm just going to call it amounts just to keep things simple. So we call it amount, and all this is going to do is subtract amounts from your bank balance. Okay, so it's going to say balance, but it has to do some checks. It definitely has to do some checks. Guys, how am I going to test this? Can I just withdraw any amount that I want? How am I going to test this? What do we have to check about amounts? Yeah, exactly. We're going to use an if statement. And in particular, what do we have to check? What do we have to know about amounts before we can withdraw it? What do I have to check about amounts? So we have an amount that we want to withdraw, and we have a bank balance in the balance property. So what do we have to know about amounts and about balance? I think the main thing we have to check, right, as the bank, is to just say, we must make sure that amount is less than balance, or less than or equal to balance. Okay, less than or equal to balance. That makes sense, right? You can't withdraw more than your balance. We're going to say that this is a debit account. It's not a credit card. Obviously, that would be different logic. But yeah, we're going to say amount less than or equal to balance. All right. And then, so if amounts is less than or equal to balance, then we can say balance equals balance minus amount. And otherwise, we'll just say else. We'll print out like invalid amounts, or yeah, something like invalid amounts. Invalid amounts. All right. So now we've got a method. So guys, the reason we programmed this up is this here, this debit account method is what we might refer to as a unit of code. And we have this unit of code, the singular method, and we can write a unit test for that method. Now, what we need for a unit test is just a few things, okay? You need the initial setup, okay? So the initial balance, we might say. So I'll call this initial. Our initial is going to be 10,000, okay? What we're going to test is what happens if I withdraw a certain amount, okay? So we'll have an initial value. We'll have a like test value, a withdrawal amount, okay? So I'll say amount. I'll just call it amounts. And let's say we're going to test withdrawing 5,000. And then the last thing we need is an expected amount. So if I create a bank account with 10,000, I attempt to withdraw 5,000. Based on how we program this here, guys, what is our expected output? What's our expected value at the end of the day? Based on our method here, what do I expect to occur? What do I expect to occur? What's the expected balance? What's the expected bank balance? Exactly, it's 5,000. And you can go like, okay, cool, that's fairly intuitive. right? This one's fairly easy example, but you can imagine what we really want to be testing is some edge cases here, right? Like, okay, withdrawing 5,000, I'm pretty convinced that this unit test will work, okay? In order to do that, let's finish up the unit test and check out what's going on, okay? So I'm going to create a new bank account, and I'm going to say, instead of using the 10,000, I'm going to set it to the initial, okay? Initial in this case is 10,000, but you can see that this would be easier to modify. So I'm going to set it to initial. I'm going to then withdraw amount. So I'm going to say Chris.debit accounts, and then I'm going to give it amount, okay, to withdraw. Then what I'm going to verify, I'm just going to have an if statement at the end here. And I'm going to say if expected, so if the expected value, 5,000, if the expected value is equal to the balance, then I'm going to say unit test passed, console.writeLine, unit test passed. Okay. Otherwise, I'm going to say unit test failed. Okay. Unit test failed. Console.writeLine, unit test failed. Unit test failed. Okay. So let's go ahead and run this. So I'm just going to run this code. Bank account can only be assigned. Let me just see where's this giving us error on line 42. Okay, yeah, that makes sense. I'm just going to create a setter for now. Okay, just to keep things simple. Okay, so you can see currently it says unit test passed. Unit test passed, because the value we expected is the value we got at the end. Now you can see, so that test was simple, but you could see how this could help us find some problems. So for example, let's say I wanted to withdraw an amount of 10,500. Okay, so let's say we set initial to 10,000. I try to withdraw the amount of 10,500. What happens now, guys? What's the amount that I expect at the end? If everything was working properly, how you expect a bank withdrawal to work. If you have an initial amount of 10,000 and you try to withdraw 10,500, what do we expect to be in the account at the end? What do we expect to be in the account at the end? Anyone know? Minus 500? Perhaps, remember we said that this was a debit account though, not a credit account. So you can't go into negatives. Yeah, so you see, AB, it really depends. So we could hypothetically fail the unit test here, but remember it depends on how we define the test, okay? Exactly, we would want it in this case to say invalid amount, right? We would want it to say invalid amount. Why? Because our initial bank balance was 10,000 and we try to withdraw 10,500. And based on how we define things here, your amount, the amount that you withdraw has to be less than the bank balance, right? It has to be less than the bank balance. In such a case where it's not less than the balance, we would print out invalid amounts, and the amount that we expect at the end would be 10,000 still, okay? Let me just clarify with you with the if statements. So it says if amount is less than or equal to balance, then balance equals balance minus amount. In our case though, because amount is not less than balance, all it'll do is print out invalid amount and no withdrawal will happen. So the expected amount at the end will still be 10,000. Okay. So when I run this, you can see it says invalid amount and then it says unit test passed. Now let's see what maybe a failed unit test would look like. So there's an even more subtle case here, guys. And this is why all I'm trying to emphasize for you guys here is why it's so important to do unit tests. What will happen if I try, let's say hypothetically, this is a weird ATM machine, or maybe they're using their, like a mobile app. What if the person tries to withdraw minus 500 Rand? Now, if our withdrawal was programmed correctly, it should say minus 500 is not allowed. That's an invalid amount. You can't withdraw negative 500. That's not possible. You're not allowed to withdraw negative 500, right? So what we would hope is that if they tried to withdraw negative 500, the amount that we would expect to have in the account at the end is 10,000, right? Because you're not allowed to withdraw negative 500. But what would actually happen with how we programmed the debit account method? What would actually happen if you try to withdraw negative 500? Let's go through it. So we would have amount equal to negative 500 is less than or equal to our bank balance, which is 10,000. Guys, is that true? Is that true or false? Will the if statement be true? Will the condition be true? Amount less than or equal to balance? That's true, right? Yeah, negative 500 is less than or equal to 10,000. That's true. So we go into the if portion of the statement. We run this line. So we say balance equals balance, which is 10,000, minus amount, which is minus 500. So what would happen, guys, if we say 10,000 minus negative 500? What would happen? Exactly. We'll have 10,500 at the end. So in this case, clearly, our method is programmed wrong. This is not how we would want to do bank withdrawals, right? Like, you cannot withdraw negative amounts. In this case, you could withdraw some crazy negative amount, like negative 5 million, and then suddenly you would have 5 million added to your account, right? Based on how we programmed this. And this is why unit testing is so important. You have to make sure that what you're programming is working for every single possible case, right? In order to pass this unit test, what we would have to do is maybe say if amount is greater than 0 or less than 0, we would have to double check, right? We would have to check if amount is less than 0, then the withdrawal must not be allowed. Okay, must make sure that the withdrawal is not allowed in such a case. All right. So yeah, it's a subtle example, but hopefully you guys see what's going on there. All right. Interesting stuff. So that's a unit test, and you can see why they're important, because there are these subtle cases, like what if they try to withdraw a negative amount? There are these subtle cases that we don't necessarily expect to work in the way they do. Okay, and that's why we do unit tests. So we have unit tests, which are testing individual methods, the smallest units of code in our system, individual algorithms, individual procedures, functions, and methods. Okay, and like I said, we now move upwards, all right? We have integration testing. So we had unit testing, where we were testing the smallest portions of code. We then have integration testing. So in order to explain this to you guys, I'll say the word integration, again, I think the levels of testing, the reason why I like this way of describing testing is because they're very well named. Integration testing just makes sense if you understand the word integration. So what this means is that the individual units of code that we tested under unit testing, they can all work individually, right? They can work individually. But when we put them together, they might break. Okay, so in order to make this make sense, I'll connect it to the bank account example that we just did. So you can picture, if we're at an actual bank, we could have a debit account method like we have currently, where you can withdraw from your account. Okay, you can withdraw from your account, and that can work. You like you've seen, we can program it to make it work in every case, and all of our unit tests for the withdrawal method could work. You could also have a credit account method, right? That adds money to the account. So you can deposit a certain amount of money into the account, right? And all of your unit tests for the credit account method could work, right? But you can imagine how these things could break when you put them together. Because you could say, let's say you have this credit account method, and you credit your account with a certain amount, but maybe the system takes a little bit of time to update the variable, to update the property, to update your bank balance. And so let's say if you deposit into the account and it adds to a certain balance stored on one part of the system, but you go and try to withdraw from an ATM that hasn't yet updated, and you could see that now, even though the credit and the debit methods were working individually, they now break together. Okay. You could also imagine another example. If we have some way of calculating interest, do we calculate interest before or after we debit the account, for example? Like which amounts do we use? So you can imagine that there's all of these special cases where individual units of code, like the way that we add interest to an account, the way that we debit and credit accounts, all of these units of code, these individual methods and algorithms could work individually, but break when we put them together. And so that's why we do integration testing. The units can work independently, but we need to test that they are working together. Okay. And then going even higher than that, we can have system testing. Okay, so at system testing, we've tested these individual units of code. We've tested how they sort of interact and interface together. But on system testing, we go, okay, the entire application is complete. The final application has been deployed. It's working now. We're basically ready to release it. We now have to test that everything is working together, working in the way that the user would expect. Okay, so it's like, this is like the final test. All of the methods, all of the things together. Okay, the entire system all together. And we'll be including things like make sure that your server is updating at the correct times. Make sure that everything is working fast enough, and that there are all of those special cases about, like, let's say someone tries to debit and they don't have an internet connection initially, or they do have an internet connection, but they lose it in the middle of the debit, like in the middle of the transaction, right? Like all of these little things that could occur when you have this entire system where you're not just testing your application in like a safe environment. All of those kinds of things need to be tested here in system testing. We're testing everything together. The application and system is now complete. All right. So those, you could see those as like a fairly all-inclusive understanding of testing, right? We've tested the individual units of code. We've tested how they interact. And then we tested the system as a whole. What else could there possibly be? But I told you there's 5 levels of testing, right? There's 5 levels of testing. So what else could we possibly be doing here? What are these 2 last ideas of testing? And this is why I like the levels of testing, because it's very specific and very like all-inclusive, if you like, or in a way. So the next level of testing is to say acceptance testing. Acceptance testing. So you can say, like, we've tested the entire system as it stands, but we now need to take it to customers and to the product owner, the person who asked us to create this application. And we have to say, look, the system is done, but do you like it? Is it usable? And that's what acceptance testing is. It's basically customer testing. So alpha and beta testing, if you guys know what alpha and beta testing are, when we release the system to an initial batch of users, that is under acceptance testing, okay? Because we're giving it to some users, we're giving it to the product owners, we're giving it to, you know, all of these relevant parties, and we're asking them whether they like the application, whether it works as they expect, all of those kinds of questions. And we can fix any problems that they're having with the system. Okay, so these are not necessarily logical problems. They could just be problems like they don't like the way it looks, or it's not working correctly, or anything like that. Could fall under, could be noticed under acceptance testing. And again, now we've got like, wow, so we've even asked customers whether they like the app. That's even considered under this levels of testing. But that's not even the final level. There is one more, regression testing. And this is basically like all of the testing that you do while maintaining the system. So we've released the system now, the customers liked it, everything is working as we expect. It's actually deployed. The application has been finalized. People are actually using it. But we now understand, we incorporate into these levels of testing the idea that actually you're still not done. It's a cycle. You're still developing. Okay. So when you upgrade and maintain the application, right, like the credit system could have been working. But when you update the credit system, like maybe 5 years down the line, you could break other parts of the system. Once you upgrade, you have to repeat the unit tests, the integration tests, the system tests, the acceptance test. And all of that repetition falls under what we call regression testing. Okay. You make sure that the app is not regressing, right? Like when you upgrade one thing, when you update one thing, when you do some maintenance, you could potentially break other parts of the system. And so that's why we do regression testing, to ensure that all of your upgrades and updates and all of your maintenance doesn't break the app. Okay. So that's the levels of testing. Those are the 5 levels of testing. And it's a very useful way of thinking about the different kinds of testing that you have to do. Okay. Cool. And then maintenance is, so we've gone through each of the phases of the application lifecycle. A lot of places call this maintenance and release, the maintenance and release stage. Okay, the maintenance and release stage. In your book, it's just called the maintenance stage, and that's cool. So here we just need to discuss the release manager. The release manager is the person who handles like the release, the packaging, the feedback, all of that kind of part of the stage. Another important thing that falls under the maintenance stage is support staff. So like, having someone to phone in if the app is breaking, you must be able to call into a call center or something and speak to people. What page, Taffy is asking. So this is on, you could see this on page 68. There's a more detailed discussion of release management, but the life cycle itself is on page 66. So yeah, the maintenance stage is just where, all of that maintenance happens, and support. The important thing that you guys must understand here is that support also falls under maintenance. So technical support staff. Okay. And that's actually the full application lifecycle. But I just want to draw your attention to something specific. So you can see it's currently highlighted in red on the screen. It's now got a box around it. It's now got a green arrow pointing at it. You guys see that maintenance connects back to requirements, right? Maintenance connects back to requirements. And the reason why I'm emphasizing this for you guys is because this is a life cycle, okay? This continues. This process never ends. When you do an upgrade, so you're in the maintenance stage, you're maintaining the application, there's people calling in constantly, things are happening on like an operational level, everything's working, the system is working. When you do an update, when you want to upgrade the application, you start the cycle again. You have to do requirements analysis on this new update. You have to design and plan the update. You have to develop the updates. You have to test the updates under regressions, but you also have to do regression testing, right? So you test the update itself, you do the system testing and all of that kind of stuff, or the unit testing, integration testing and system testing. But because of regression testing, you also have to rerun all of your previous tests to make sure that your new update doesn't break anything that was previously working. So you do testing again, and then you have to maintain this update as well. You have to release and maintain this update as well. So it's a permanent life cycle. Whenever you do an upgrade, it repeats. Okay, so it's like a repetition. All right, and this does fall under other names. Another thing that we call this is often agile development. And it's also this idea of a cycle. And you see it's quite similar. So meet and plan, that we could consider like requirements, design, code and test, release, feedback. You don't have to remember this one. You must know this one. But like this, I'm just showing you that this is used. Like there are other ways of referring to it. And yeah, so this is not the only way that this is defined. This is like a very popular idea. It's a very popular way of understanding software development. Okay, cool. So that actually brings us to the end of the initial part of chapter 3. Where there's still a lot to go. As I said, by the end of chapter 3, you guys will be finished with a very large portion of first year university computer science. But what we're going to do now is I'm going to actually show you an example of how the ALM might influence real world development. Okay, like a real world application. And this is like a real world app that I've been developing with like students, basically. So each class has added their own thing. I've done 3 other classes for the MTA. And each class has added their own thing to the app. It's a very simple app, a very gross app. You can visit it at, let me just get it for you guys. You guys can visit it on your own devices, bfmta.herokuapp.com. This is it. It's not the prettiest site ever made. That's not even the intention. It's just to show you guys an example of how we might take a new requirement through this entire process. Okay, just to show you, because like obviously in the real world, it's nice, it's great having that neat life cycle, but in the real world, things aren't always that neat. Things are a little bit, you know, things can be a little bit broken. So I can also show you this. So if you visit this URL over here, this is on a website called GitHub. There are other versions of this, but essentially what this is doing is release management. So it's tracking all of the changes that have been made to this code. Okay, so I can, let me just make sure that the latest changes have been made available. It looks like, yeah, they have. Cool. So you can see if you click here on previous commits made, so you can see these are all of the commits I've made to the site, okay? And you can click on any of these. So by commits, I mean code changes, all of the changes I've added to the site. And you can click on any of them and you can see the exact line of code that was changed. Every single line of code that has ever been changed is tracked by Git, okay? It's called Git. But again, you guys don't have to necessarily remember all of this. I'm just showing you how this might work in the real world. Okay. The next thing I want to show you guys is just how we might do requirements analysis in the real world. And what we usually use for this is a storyboard like this, or some kind of like to-do lists almost, a backlog, a product backlog. So you can see on the left here, we have some potential changes that students have asked me to add. Okay, so we've got some potential requirements on the left here. There's nothing currently being worked on. We haven't worked on this app in a very long time. And these are the 3 things that we've done. Okay, we added a GIF to the site, we added a Rickroll button, and we added a green background. Okay, so that's what we've added to the site. And you can see that those changes are reflected on the site. So again, we could, there are plenty of ways that we could modify this. We could center align everything. We could change that hello world to a more meaningful title. What I want to do is, guys, are there anything that you want to change about the site, you yourself? If there's any student who wants to change something about the site, you're welcome to request it. I think it might be, I'm thinking that it might be nice to center align everything, maybe. We could try to center align everything on the site. We could add that as a requirement. It might be, maybe if you want to change the background, if any of you wants to change the title to a certain thing. What do you guys think? What should we change? Does anyone have any ideas on what?
Can you add a click button? Can you add a click button?
Add a click button.
Yes, sir.
Well, so we do have a button already, Taffy. Like if you click free V-Bucks, it'll reroute you to Rick Astley's Never Gonna Give You Up. See.
Oh, yes.
So this is a Rickroll button. So if you click it, it'll reroute you to that YouTube video. I think, shall we center align everything? We can go through the different options here. So I'll add a requirement. So I'm going to add a little note. I'll say center align site. Okay. So I'm just going to add that as a requirement. See, like that. Done. And it's added. Now you can go through all of these options. So these are the options that we have here. Someone suggested that we center align the site like I just did now. Someone suggested that we add a little free V-Buck icon somewhere on the website. That would be maybe quite cool. We could make a blue font color, so make the title at the top blue. We could add some kind of artsy banner or something. Someone was suggesting. We could add a logo to the website. That's quite cool. We could add some kind of game. That would be quite difficult. We could add audio to the site. Okay, so we've got a lot of options here. Okay, I'm going to say that we're going to center align the site. So this is requirements, right? We've got all of our requirements on the left here. What we're doing currently is requirements analysis, right? So I'm going to pull the center align site to the middle here. It's a progress because we're going to work on this now. We're going to achieve this goal. Okay, so currently it looks like this, and we want this to be centered. So we've got a requirement here. We now need to analyze it a little bit more. So this is not technical. This is what a business person might say. They might say, please center align everything on the web page, right? They might say something like that. You know that we need to make it slightly more technical than that. So there's an idea. In order to center align the site, we're going to have to use a concept that we'll only learn about in chapter 4 called CSS. But don't worry, you guys will learn about it in chapter 4. So I'm going to say use CSS. So we've got this broad, remember, we've got this broad requirement here, center align site. I now, as a business analyst, I'm going to convert it into more technical requirements, okay? Something that a programmer can actually use. I'm going to say use CSS in the body tag to center align site. Okay, you guys might not know what that means yet, and don't worry, I'm just showing you an example of how the simple requirements will be taken through the entire application lifecycle. Okay, so I'm going to create this more technical requirement here. I might even go more into detail. I might do more planning. I might say CSS center align. Okay, CSS center align. We can Google it. We can do some research, like find out how this might be done. In this case, I think this command over here, adding text align center, I think that command will do it for us. I'm going to go over back to our issue here. And just for the programmer who implements this change, I'm going to put text align center over there, just so that they know exactly what they need to do. Okay. And I'm going to hit convert to issue. I'm not sure why it didn't convert. Let me just make sure quickly. That's a little bit annoying. I don't know if I clicked exit accidentally, so I'll just retype it quickly. Use CSS to center align site. Okay, and there we go. It's converted to an issue. You can now see this is in progress. This is now in progress. This is what we're working on. Cool. So guys, we've done requirements analysis. We've also done planning, like design now, right? Because I went and fetched text align center. What's next? What do we do next, guys? According to the application lifecycle, what do we do next? We've done some planning. We've done some requirements analysis. What's next? What's next on the agenda for this little change that we're making? Anyone know? If you take a look at your application lifecycle, what do we do next? Okay, cool. Yeah, exactly. We would go through design or planning. I'm going to say that we've done design or planning. This is obviously one very simple change. What you might want to do as well, if you were in an actual company, is you would maybe draw what it would look like afterwards. You might draw what the centered version of the site will look like, what we expect it to look like. But let's say we've done that. Our planning was putting this little text align center there. That was our planning. I was planning how I was going to do this. I was planning that I'm going to use CSS. That's the programming language I'm going to use to do this. So let's say we're done with planning. Okay, we're done with design. So what's next? What's after design? Development, exactly. So we now go and actually make this change. And actually, we've done the difficult part. The planning was actually the difficult part. Figuring out exactly how we're going to do this, that was the difficult part. In order to develop this, I'm just going to open this on my home computer. Okay, this is the site. This is what the site looks like in code. And don't worry, guys, you will learn about how to program this yourself, and you'll learn how to deploy and create your own website, exactly like we've got here. That's in section 4. But for now, I'm just going to add a very simple command. Okay, so I'm going to say text -align center. Okay. Ooh, we have to spell center like an American. Okay, we have to spell center like an American. or then CSS won't understand what's going on. Let me just make sure so I can refer back to my design, text-align center. That's how we're doing it. Is this similar to HTML? It's 100% HTML. Yeah, exactly. Well, HTML, CSS, and JavaScript is what we're going to be learning in chapter 4. But yeah, 100%. Sounds like you even have a little bit of a head start. Okay, cool. So we've got a simple thing going there. Okay, so it's now aligned center. What's next, guys? Let's say that was the development stage. What's next? We did some developments. Adding that little line was our development, text align center. That's now center aligned. Exactly. Next, we go into testing, right? Because obviously we've made the change, but that's not convincing. You want to see a result, right? You want to see a result. But now's the interesting bit. We need to make this distinction. So this is the live site, bfmta.herokuapp.com. Okay, that's the live website, the website that our users can actually visit. I haven't tested this change yet. I don't want to have that change reflected on the website itself, right? I don't want that to happen because we don't know if it works yet. We want to make sure that everything is working. So in order to do that, we're going to test it on my computer, okay? So in order to do that, I'm going to say, I'm just going to tell it to use my computer as the server, okay? So I'm just going to run the server locally on my computer, okay? So it's just booting up. It's like running the server. It's going to take a little while, but it'll be done soon. And so this is testing, right? I'm just testing that making sure that the change works. Okay, making sure that the change is properly implemented. Okay, it's finished. The server is open. So I can now visit it on my own computer as if it was like the server itself. Okay, if I go to localhost 8000, it'll bring up our site. And look, that looks centered. I'm going to say like, okay, in this testing stage, I think it would be better if the free V-Bucks button was on the next line. I think that would be better. So I'm going to go ahead and move the free V-Bucks to the next line. Okay, I'm going to add what's called a break tag. Also very simple. I'm just going to add BR over there. That's it. That's the whole change. It's just a single line. And you can see the free V-Bucks is now on a new line. I'm going to add another break just to make it so that it's even more on a new line. So you can see it was just touching the GIF. Now it's got some space. I think that looks good. I think that's what we were visualizing in the design stage. That's what we were visualizing. Okay. Now, this is all on my computer. You can see the actual website is still exactly the same as it was before. We've now finished the first stage of testing, but there's more, right? This was maybe what you could call like a small test, even a unit test, you might say. I was testing just that change of code. I now want to make sure that the entire system works together, right? Like this must work on the server. It works on my computer now, but I must make sure that it gets through all of the processes. It must work on the server itself, okay? So what I'm going to do is there's actually two applications. So you can see there is bfmta.herokuapp.com, and you can visit that. But there is also bfmta-staging. We have what is called a staging application. And so this is a place where I can test on the internet. So I can test it as if it's live, exactly how the actual server is, except this server is separate. The user won't be visiting this server. So it's like a safe place to test things on the internet itself. Okay, so I'm going to go ahead and change. So you can see currently bfmta-staging.herokuapp.com has not been updated. What I'm going to do is I'm going to push our latest changes so they are reflected on the staging application, not the final application yet. We still have to test it before it goes to the final application. But I'm going to commit it. So I'm going to say git. Again, you guys don't have to remember these commands. You won't be tested on git. I'm just showing you what the full cycle might look like in a simple business. Okay. I'm going to say -m just to add a little message. So I'm going to tell everyone what I did. I'm going to say that in this change, I center aligned the web page or the home page, something like that. Center aligned the home page, git commit. I'm then going to say git push origin master to push all of these changes to the to the internet. So currently they're all on my computer. I'm going to go over here. It's going to ask me for my password and stuff to make sure that I have permission to update the site. And there we go. So now I must quickly jump back here. If I refresh over here, so I go back to the code page, you can see that my latest change was added. Center aligned the home page 30 seconds ago. Okay. The other thing, we've got a full graphic here, like a pipeline. You can see it's currently building the application. It's building the application. Let me open it. So you can see it's going through a whole bunch of steps. It might apply a whole bunch of tests. It's going to make sure that everything is working correctly, process the whole app. It's done. It's finished processing the site. It's launching the application, and it says release version 16. Okay, version 16 has now been released. Okay, so now if I go to the staging application, so bfmta-staging.herokuapp.com, and I refresh, you can see it is now center aligned. Okay, it's now center aligned. The final application is not yet aligned. You can see that the final application has not changed. Okay, so what I do, I check the staging application. This is on the internet. My users can visit it. I can do some alpha and beta testing on my staging application, make sure that the product owner and the business is happy with how this is working. And when I'm happy that this stage is ready to be released, I can come here, I can hit promote to production. I can click that button. It can tell me it's going from BFMTA-staging to BFMTA. I hit promote. And you can see release version 9 of the actual site. I can go back to the actual website now. So bfmta.herokuapp.com. I'm going to hit refresh, and you can see it is now center aligned. Okay, so we have taken that change through the entire application lifecycle. Okay, from start to finish. What we have to do now is like maintain it and make sure that everything is correct. So what I'm going to do is jump back to our little requirements page. I'm going to take the center aligned site. I'm going to move it over here, and I'm going to mark it as closed. This is finished. Okay, so I'm just going to go over here, hit close issue, and you can see that that'll just close now. There we go, closed. And so that was it. We took a change through the application lifecycle. All right. So that was just me showing you like what this might practically look like, just to give you guys an idea of what that might, of what the application lifecycle looks like in practice. And you could see that we had all of those other requirements on the side there, right, in to do. And every single one of those requirements would go through that entire lifecycle, and slowly we would upgrade the site. Okay, and continually make sure that everything works. All right, so that is that. Cool. So I think it is time for us to take a little break. I think we'll break until 10:05. When we come back, we're going to do a little quiz on the ALM stuff, and then get started with, well, what will bring you to the end of first year computer science, data structures. Pretty hectic for some of you to be learning this at your current ages, because it can be pretty complicated stuff, but it's cool. It's quite cool. So yeah, we'll get started on that when we come back. So yeah, let's take a break, go and have some water. Let me close all of this because we are done with that. Cool. Be back now. Just gonna go get some water. Summer has really started. By the way, guys, if you're there, even though we're on break, you can get started joining the quiz. Menti.com 827666. That's the code. Your pretty ominous last three numbers there.
Sir,
Yeah.
sir, do you think life will ever be the same?
Life will ever be the same after what? Oh, after
After
coronavirus, of course. Obviously, that's
Yeah.
what. I don't know. Tough question. I think so, hey. Just because I think people are going to get a little bit fed up.
Sir, don't you think that they're planning something else? Like this whole corona thing is all part of an agenda.
Maybe. I don't know.
Like, if you watch Joe Biden's interviews, he said that the United Nations are planning a one world government, which is the new world order.
Yeah. Well, I mean, I think just in terms of how, Taffy, you must look into, there's a nice set of lectures by a guy called Rick Roderick. Rick Roderick. He's like an old philosophy professor. And I really enjoyed these lectures because it's almost like it's quite cool how there's a philosopher called Jean Baudrillard. And it's quite interesting how it's like a different way of thinking about these things, I think, where it seems almost like you can definitely attribute it to malice, I suppose, which like or people trying to control us or something like that. And there are those kinds of theories like Society of Control by Gilles Deleuze. But there's a nicer way, I think, of or not, it's pessimistic, but it's almost like post-modernity makes this inevitable, like the developments of technology and how we're becoming like simultaneously more connected with one another, but also more separate. Like, the internet connects us with people far away, but also keeps us separate on like an interpersonal level.
Yeah, true. So don't you think that so people these days are sacrificing peace, privacy in the name of peace and security?
Yeah, I think that sounds pretty accurate. Yeah.
So everything is gonna be tracked someday, some or the other.
Yeah.
Do you know how they're gonna track us?
Probably how they track us now. I saw a Gmail sent me a pretty creepy email recently about how like the exact places I visited in the last month and how many miles I've traveled and all of this stuff.
Exactly. Even with the Apple Watch, it shows you how long you wash your hands for.
That's crazy. It is. It's yeah. You must. There's nice lectures on what's called societies of control, because it's like I don't know if you've heard of Michel Foucault. It's like quite it's like quite a cool analysis of how like society developed from sovereignty, like back when you have a king, like the king defines the law, and like punishment is like a revenge of the king, if you like. And then we went into societies of discipline, which is like sort of, we kind of have this now, but we're evolving away from it, is the idea at least. So like societies of discipline define like spaces of control, like you go to work at a certain time. Like, for example, a king might just tax production, right? Like if you're a serf working on a farm, you work the farm in whatever way you want and you give a certain amount to the king. But in a society of discipline, you go to work and your whole day is controlled, right? Your whole day, exactly how you produce, it's standardized, everything, or organized, if you like. But then even away from that, what we're moving into now is like a society of control, where it's not even like in a particular space, right? Like with ideas of overtime, and I can't explain it as well as the philosophers.
No, I understand what you're saying. So also with like the Bill Gates Foundation, it says like the slogan of Bill Gates Foundation is population control and reduction.
Yeah, and he thinks that sounds like a good thing.
What?
He
And
thinks
also,
it
if it,
sounds good, which
yeah,
is
if you think
crazy.
about it, if you think
Mm,
about it, whoever controls the money controls the world.
mm, mm,
Like the Federal Reserve, they controlling America, not the American government.
mm.
Yeah,
Yeah, we live in a weird time.
weird, weird time. But you know what? We all have a purpose.
Mm.
Good
Okay,
talk.
everyone, join the enough philosophical discussions. It is now time to study. Join the Menti quiz. 827666. Okay, I see one person's joined. I'll click through. So this will just test us on what we covered like this week and last week, basically all of the ALM stuff. I'll just make sure that's okay. Yeah, cool. Okay, so yeah, I see two of you are already here. I'll wait until more of you join. Let's see. So there are 6 people currently attending, and I think one person was on holiday or something. So cool. I'll wait until a little bit more of you get in. Okay, 3, that's cool. Give you guys another minute or so to join. All right. I'm gonna get started. Remember, you can join the quiz midway. No harm in it. It's just for practice, really. Cool. 5. That's cool. I think one more person. Give 10 more seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's go. Okay, I hope I did verify. I think you guys should know the answer to all of these. At which stage of the application lifecycle would we create a unified modeling language diagram specifying the layout of the program? So there's a keyword there that should help you answer this, even if you're not familiar with UML itself. There's definitely some keywords that should help you get to the answer here. So a unified modeling language diagram, UML. I mean, I suppose it's also like the stage where we would make a diagram for like the layout. You know, where would we decide upon layouts and diagrams and models and stuff? I think I've probably given this one away a little bit too much now. Okay, actually there was a fair split here. Okay, so remember guys, even though, so it is a diagram, so in a way it's quite technical, but that would be created at the design stage, okay, because it's planning the layout of the program. Planning, like if we specify the layout of the program, that happens under design. When we actually create it, that'll be actual development, right? Cool, but not too bad. Okay. Let's go, question 2 of 5. At what phase of the application lifecycle do we monitor and manage the deployed application? So at what stage of the application lifecycle would we monitor and manage the deployed application? I did put a little trick in this one, so I'm keen to see. I don't know why I gave 80 seconds for these. That's very long. It's okay though. Okay, still 3 got it, so that's cool. So let's see. So regression testing was the trick I put in, because obviously when we're monitoring and managing and updating the application, that definitely falls under like regression testing in a way, because that's when we're doing testing. The key word that you must look out for here though, is it says at what phase of the application lifecycle. It doesn't say at what stage, at what level of testing. If it said at what level of testing do we monitor and manage the deployed application, we might say regression testing. But it says at what phase of the application lifecycle. And regression testing is not a phase of the application lifecycle. It is a level of testing. Maintenance, that's correct. Glad no one said design. Development. So remember, in developments, we're creating the deployed application. We're creating the system. So there's no deployed application to monitor and manage at the development stage, because it hasn't been created yet. At the development phase, because it hasn't been created yet. Okay, question 3 of 5. Did I give 80 seconds for this one again? Let's see. When we combine units of code together and test the interfaces between them, we call it testing. When we combine units of code together and test the interfaces between them, we call it testing. What do we call it? Fill in the blank, this one is. Hopefully this will just cement everyone's memory, considering I suppose we did just learn this, maybe. But it's good to double down on things. I think another person joined. That's cool. Welcome. When we combine units of code together and test the interfaces between them. This one isn't too bad, because again, in the question itself, they use a related term, definitely. Let's see what people say. Okay, 4 out of 6, not bad, not bad. So let's see. When we combine, so someone might have answered units because units is used in the question. But remember, unit testing is where we test units of code. However, here it says we're combining units of code together and we're testing the interfaces between them. So we test the interfaces between the units. That's no longer unit testing. That's integration testing. Regression testing is when we're testing updates, upgrades, and maintenance of the application to ensure that they don't break anything. Okay, so we're ensuring that the application is not regressing while we're updating. Okay, and so yeah, integration testing is correct. Nicely done. But yeah, integration, interfaces, definitely related words. What do we call a program designed to assist in achieving a specific task? Now, this one's just a trick. I'm just introducing you guys to this, this definition. Remember what section we're in. I'll tell you that. Think about what section we're in and think about what they would be asking about. But I'm just showing you this because, so I was going through like, obviously what questions the MTA would ask you. I saw this one and I was like, this is really not a fair question. I don't think they give enough detail. I don't think this is a very good definition, but it is a definition that you must know. Okay. Okay, I expected this to go crazy. I agree, this is a very weird question. Remember, we are in chapter 3 and we're in sort of 3.1, which is called the application lifecycle. So in this section, when they define something like this, they are referring to applications. That is the definition of application that the MTA uses. Don't feel bad if you didn't get this one. The first time I saw it, I wouldn't have gotten it, I don't think, because it's just like, this is a very weird definition of the word application, I personally think. Or at the very least, it's as true of an application as it is for an algorithm. But yeah, whatever. It is a weird question, but yeah, that is how they define application. So just cement that into your brain, okay? When they say program designed to assist in achieving a specific task, particularly when we're in chapter 3, that is an application. Okay, cool. And last question. Which level of testing contains alpha and beta testing? Which level of testing contains alpha and beta testing? So for those of you who are not familiar, I know people who play games are probably very familiar with these two ideas. Alpha testing is like a very initial small batch of first users, just to test like the important features of a program. It's almost done by alpha testing. It's almost finished. And then beta testing is just like a larger version of that, larger scale, more open, still not 100% done yet. Things like security are finished, but maybe there are some optimization problems still needing to be done. It's not necessarily working at its fastest speed. Might be some bugs still. So that's what we would look for in alpha and beta testing. But it's initial users. So when we're taking the product to some initial users, asking them what they think. Interesting. Okay. So, yeah, so the reason why this falls under acceptance testing is because it's when we take it to users, right? We are taking the product to users and we're asking them what they think of the product. We've also got, so regression testing. Regression testing is very specifically, you must be looking for the words maintenance, upgrades, and updates, okay? You must very specifically be looking for those words. It's after the application is totally finished. And remember, beta testing, the application is still not finished, right? We're still working on it. We're still finding out whether users like it, whether it's usable, whether it's working the way that they expect. System testing, you know what, admittedly, I do get where you're coming from because in a way you are testing the entire application altogether, but system testing is something that happens in-house. It's something that we as developers do. It doesn't involve users. As soon as something involves users or product owners or the business itself, then it is acceptance testing. Okay, cool. But nicely done, guys. I think that went well. I think, okay, well done, Chris. You're fourth. Okay, so Chessman as well. You did great as well. You both got 4 correct. Just Chris was slightly quicker on the draw. Okay, nicely done, guys. Cool. So that brings us to the end of the application lifecycle, which is good to get through. We can now go on to data structures. And by the time we finish the next 2 sets of slides, you will be at the end of first year computer science. So well done. And I think you guys have been managing quite well, especially since we've been on this faster schedule. Okay, great. So there are 4 kinds of data structures that we will be learning. You guys don't know what data structures is yet, so that might be meaningless, but let's just get started, get into it, see how far we can get today. You already actually know one of them. So data structures are the different ways a computer can store data. Okay, and data is a plural word. For those of you who don't know, I know it's a pretty strange thing to know. The singular version of data is datum. So whenever we say data, we're talking about lots of it, okay? It's always plural, it's always plural. So data structures are the different ways a computer can store data. Okay, what do we mean by data? So you can see it like basically information of different types, I suppose you could say. Let me find a quick thing for you guys. There is like a nice way of thinking about it. But yeah, you guys know that we have variables, right? You guys know that we have variables. So data is basically just considered unprocessed information, or like information is processed data. That's a nice way of thinking about it, I think. But a more literal way to think about it in terms of how we use it in programming is that you guys know we have all of these variables, right? We have strings, we have integers, we have doubles, and you know we can have a string, right? You can say int x equals 6. string word equals name, double balance equals 10,000, right? We have all of these different data types. Bool flag equals true, right? In particular, data structures are when we have many strings, many ints, many doubles. How do we do that? You guys know how I store a single number, right? Int x equals 6. But what if I have 50 integers, or 100 integers, or 1,000,000 integers, or 1,000,000,000 integers? How do I store that data? Okay. And there are 4 ways we'll learn to do this. There are 4 ways we'll learn to do this. There are others. There are many other data structures. There are not only 4. We will just be learning 4 in chapter 3, and these are the main ones. These are very, very important data structures. So the one you already know, okay, arrays. You guys know how to create arrays, and you guys know that it's just a collection of strings or integers or whatever, but we'll go more formally into what an array is, what its advantages are, what its disadvantages are, what it's used for, what its internal, like what the computer's internal representation of an array is, all of those kinds of ideas we'll explore. And the 3 other data types we'll be going through are queues, stacks, and linked lists. Queues, stacks, and linked lists. All of them very important. All of them have their own functions, their own uses, and we'll go through all of those. Some of them you'll actually already recognize and understand quite intuitively, I think. And about each of these 4 data structures, we'll be going through a set of questions, okay? So the first question we'll answer about each of these data structures is, how does the computer represent the data structure? So what is the computer's internal representation of that data structure? And we'll start building up like a mental image of how the computer stores each of these things. How do we create the data structure? So how do we actually create one in C#? How do we actually use it? How do we actually create it? How do we access items in the data structure? So you guys know in an array, if I have an array and I access names in position 0, that's how I access the array. But how do I access a queue? How do I access a stack? How do I access a linked list? So we'll be exploring those questions. How do we manipulate the data structure? So how do I change items in the data structure? How do I delete items? How do I, generally manipulate it, work with it? Okay. And the last question we'll answer about each of them is, when would we use it? When would we use that particular data structure? And obviously, these are very important questions to know about computing and computer science in general, because usually when we're working with computers, it's because we're working with large amounts of data, right? Too much for a human being to handle. There's just so much of it, and we have to be able to process it in a very fast, efficient way. And that's like the main problem that computing solves, in fact, is how do we do those repetitive tasks on huge amounts of data. Okay, cool. So we're going to start where I think it makes sense to start, because you guys already know this data structure. So we'll go through some of the ideas relevant to it. Okay. So first, we're going to start with the definition. Definitions are cool, but they only really work after you understand, I think. But here's a definition of the word an array. An array is a collection of items of the same type. And the other way we say that, so the same type means homogeneous. What do we mean by that? In an array, we have a lot of ints, right? Or a lot of strings, or a lot of doubles. You don't have an array with like string int double. You don't have an array with Boolean string double. Everything in an array is the same type. It is a homogeneous structure, Not all of our data structures are homogeneous, but arrays are, because of how they work, okay? And they are stored in contiguous memory. What do we mean by contiguous? That means it's all next to each other. And I mean that literally, okay? In the computer's memory, everything in an array is stored next to each other, literally in the computer's memory, okay? So let's go through some examples of arrays before we discuss more in detail. So here we have an array of integers, right? So we've got 4 integers. These are our values. These are what we call the values that the array is holding. So 5, 6, 3, and 4. And each of those numbers has an index. Okay? They each have an index. So 0, 1, 2, and 3. At index 0, we are holding 5. At index 1, we're holding 6. At index 2, we're holding 3. At index 3, we're holding 4. Okay. Great. So we're going to go through the way we can create this structure. Okay, so there are a number of ways that we can create arrays. In particular, you guys should be familiar with 2 of them. Okay, one of them you already know, and that's the one I'll show you first. But there is a second one that I want to just show you guys quickly. Okay, so first things first, let's jump over to Rex Tester and create some data structures. Okay, so we're going to start by creating an array. So the way you're most familiar with of creating an array is to just say int, so the type that the array is holding, some square brackets, the name of the array. I'm going to call mine numbers. So int square brackets numbers. So this is the name of our array. This is saying that it is an array of integers. We're going to say equals, and then you guys give it a list, right? So in this case, we are holding 5, 6, 3, and 4. So we would say 5, 6, 3, 4. So that's one way I can create an array. Fairly decent way to create an array. All right, not too shabby. It is not the only way to create an array though. And the main thing that I want to the reason I want to point this out to you guys is because you can picture a situation where this is not enough. Okay, let me describe. Let's say I have an array. So this array holds 4 numbers, right? They are 5, 6, and 3, and 4. It holds 4 integers in particular. Now, you can imagine a situation where I want to be able to hold like 100 numbers, right? Let's say I know I'm hosting an event and there's going to be 100 people attending, and I want to give each of them like an ID number at the event. Okay. So you can imagine that situation, like it's quite a reasonable situation. It's quite a reasonable request to expect of a computer, but you don't yet know what number each person will be assigned. Okay? You don't yet know what number each person should have. So in such a case, you know that you want to store 100 integers, but you don't know what those integers are yet. Okay, so I'll do it now. The other way of creating this is to say int. So this is saying it's an array called nums. Okay, so this time it's called nums. You could call it whatever you want, really. I'm going to say equals. Now, we don't know how many numbers we are storing. We do not know how many, we do not know what numbers we are storing. Sorry, I don't know why I said it that way. We do know how many we're storing. You have to know how many you're storing because it's all in contiguous memory. So the computer needs to know how much memory to save, okay? We do know how many we're storing. We don't know what numbers we're storing, okay? And so in order to solve this problem, you can create it like this. Okay. So this is saying, I want an array called nums, and it must be able to hold 100 integers. Okay, that's the size. 100 integers, it can be 1,000, 10,000, 100,000, 1,000,000, whatever. It can hold as many as we want, okay? That is holding 100 integers. Okay, so those are the 2 different ways that you guys need to be familiar with of how to create an array. Okay. Now you might say, how is it doing this? How is it reserving 100 integers worth of space? This is the same as essentially creating a new array like this. So 0, 0, 0, 0, 0, 0, 100 times, okay? Giving it a list of 100 zeros. That's basically what it does. Okay, if you say new int 100, it's created an array of 100 zeros. That's what it's done. Okay, that's all that does. And if I made this 1,000, that's going to be 1,000 zeros, 10,000 zeros, and then you can go and change them manually yourself, okay, with a for loop or whatever. Okay, cool. So those are the 2 ways we need to be familiar with of creating an array. And also, I just want to emphasize for you guys, arrays can be of any type. Okay, they can be of any type, but they have to be one type. So for example, we can also have the second array here where it's dog, cat, right? So there's strings now, dog as a string, cat as a string, and they'll be at index 0, 1. Okay, the indexes are still like the same, right? It's still 0, 1. And if we added another one, it would be 2. If we added another, it would be 3. So you can picture that that's still identical. Okay. And the only difference is this is now an array of strings. Cool. How do we access an array? That's another question that we needed to ask. Okay, how do we access an array? And that's quite simple, really. So if I wanted to, in fact, you guys can tell me, console.write. If I want to print out 3, guys, how do I print out 3? What will I put in console.write here? How will I get 3 out of that array? Exactly, we'll access numbers in position 2, right? Numbers in position 2. Let me zoom out a bit so that you guys can see when I run it. And you see that gives me 3. Now, as I told you, I'm just going to show you, while we're discussing how to access an array, I'm just going to show you guys that in this array of 100 integers called nums, so if I access nums in position 0 and print that out, as you can expect, it gives me 0. If I access nums in position 90, that'll give me 0. If I access nums in any position, it's going to be 0. This is a list of 100 zeros, a collection of 100 zeros. So if I access 99, that's going to be a 0. But if I access 100, okay, run it, it breaks. Okay, it's index out of range exception. Why? Because this was a list of 100 integers. So it held 100 zeros. I try to access the 101st item in a way, because we start counting at 0. And you can picture why that would break. That doesn't exist. That memory is out of bounds. I do not have access to that memory. Okay, I created an array of 100. So that's what I have access to, and they're all zeros because I didn't specify them. Okay, cool. Next, we can say, the next question is, how do we manipulate this data structure? How do we manipulate this data structure? And this you're also familiar with. It's fairly simple. You can manipulate it exactly how we manipulate any other variable, right? You give the name, the index you're trying to access equals whatever the new value you're setting it to is. So let's say I'm going to change the 77th 0 to a 1. So I'm going to say nums in position 76, because we start counting at 0, equals 1. And I'm going to try out, I'm going to print out nums in position 76. And then I'm going to run it, and you can see it's a 1 now. It used to be a 0, it's now a 1. And if I set that to a 10, it would be a 10. So that's how we update the array. Okay, we access it in a particular index, and we can set it to whatever we want. Okay, not too bad. Okay, the next important question, and the last question we're going to answer about arrays. We are going to discuss arrays in a lot more detail because it's important to understand. But the next question is to say, when do we use them? Okay, yeah. So in order to understand when we use arrays, you need to understand a little bit more about what the computer is doing when it's representing, when it's using an array. Okay. So we're going to go a little bit more in depth on this. Okay, so I have this simple array here, 5, 6, 3, 4. Okay, 5, 6, 3, 4. You can picture this is in the computer's memory. And I told you it's homogeneous and contiguous, right? So the array only holds integers. The first integer is 5, the second integer is 6, the third integer is 3, the fourth integer is 4. Okay. So they're all next to each other in the computer's memory, and you can picture the computer memory as like this. And where the red is, I can't access, right? I can't access this array in position 4, right? Because that would attempt to give me something here, and that is red. It is out of bounds. That's the computer is using that for something, right? And likewise, I can't access the array in position -1 or something, because that is also out of bounds. Okay, it's out of bounds. So that is the structure, okay? So that is our array. That is what is within bounds, and all that memory outside of it is not ours, okay? So we asked for 4 integers, right? We asked it to save us 4 integers. Let me hide it. I don't know if anyone actually read it. So let me guys ask you, how large is an integer? How large is an integer? You guys remember this? How large is an integer in C#? how much memory does it use? How much of the computer's memory does it use? 32 bits, right? Yeah, 32 bits. How many bytes is that? How many bytes does an integer use? Just to, okay, Chris says 4 bytes, 100%. That's correct. So 4 bytes or 32 bits. Now, this is why an array is homogeneous. It only holds integers. Okay, this array only holds integers. If it was a string, it only holds strings. And the reason it does that is because it's important that everything is of the same type, the same size. Okay, and that's because of how it's accessed. Okay, we asked for 42, we asked for 4 integers. We asked for 4 integers. Okay, an int is 32 bits. It doesn't matter what int we're talking about, right? A 0 is 32 bits. Million, 32 bits. 2 billion, 32 bits. Every integer is 32 bits. They're all the same size. Okay? Doesn't matter what integer it is. So when we asked for 4 integers, exactly 128 bits of memory was reserved for us. And it's all next to each other, right? We have 32 bits, 64 bits to get us to the end of the 6. What is that? 96 bits to get us to the end of the 3. And then 128 to get us to the end of the 4. Okay. Yeah, let me just make sure my math was correct on that. It was, yeah. So cool, we got through. So that is how much, if we reserved another integer, that would get us another 32 bits, right? That would take us to 160 bits. Okay, so exactly that many bits was reserved in memory, okay, all next to each other. Now what this allows for, and we'll explore the maths of it a little bit more later, but what this is saying, so you can picture, the computer knows where the array starts, right? The computer knows that the array starts over here, okay? And it knows that everything in the array is 32 bits. So that's 32 bits, that's 32 bits, that's 32 bits, and that's 32 bits, okay? So when we say we're accessing it in position 0, so if I'm accessing the array in position 0 to get 5, okay, that's over here. Forgive my drawing, guys, I'm using my trackpad. Okay, that's over here. If I'm accessing in position 1, that means I'm accessing it in whatever the start location of the array is, plus 1 times by 32, right? Plus 32 bits. Okay, and that'll get me to the 6. If I'm accessing it in position 2, that's going to be 2 times by 32 bits. I'm accessing the array at the 64th bit. That's going to get me to 3. Okay. So what this means is that the computer instantaneously knows where every item in the array is. Because they're all next to each other and they're all of the same size, the computer instantaneously knows where everything is. Okay. This allows for instantaneous access. So if you are frequently accessing all of the items in your data structure, you're frequently accessing every single item in the data structure, then an array is very useful because it allows for instantaneous access. Okay, if you're I should say, if you're accessing them in a random order, if you like. If you're accessing all the items, you're not sure which item you're accessing when, you just need fast access to all of them. Okay, then we use an array. However, this is also where a problem of arrays come in. Okay, so here we stored 4 integers, right? We stored 4 integers, and we can have very fast, instantaneous access to any of those 4 integers. But what if I actually wanted to store 5 of them? So I created an array with 4 integers, and I go like, okay, I actually now want 5 integers. Okay, I actually want to store 5 integers rather than 4. How can we do this? Well, we would need to create a totally new array, right? And copy everything across. Because you can imagine there's no space here. This memory on the right here, that's not ours. The memory on the left here is not ours. There's no space for a 5th item next to the 4. There is no space. In order to get that, we would have to find a new place in memory with 160 bits all next to each other. And we would use that to store our array. We would copy across the 5. We would copy across the 6. We would copy across the 3. We would copy across the 4. And then we would have our 5th place for whatever number we wanted to store. We would have to create a totally new array, and that is very inefficient. That takes forever. You can imagine if we had 1 million integers, and then we realized that actually no, we need 1,000,001 integers. That is going to take us 1,000,000 operations at least to create that new array, copy across all of the 1,000,000 previous integers, and then add that extra one integer that we wanted to store. So you can imagine that's very inefficient. We might want a different data structure for that. Okay. So when do we use an array? If you are certain about the amount of data you are storing, okay? If you are certain about the amount of data you are storing, you are going like, I need 100 strings, exactly 100, and I don't need any more, I don't need any less. Okay. Or you are accessing all of the data very frequently in like a random order. Like you're not sure exactly which bit of the data you're accessing at which point, but you need fast access to everything. Okay. Then an array is good. Okay. In these cases, an array is very good when you need instantaneous access to your data and when you're certain about the amount of data you're storing. You can imagine though, that's not always the case, right? There are other cases where we might want something slightly different. And so that's why we are learning these other 3 data structures, because they will allow us to solve those other problems. Okay. So the first one we're going to explore, the first of these new data structures that we'll explore, is called a queue. A queue. Now, from the word queue in the real world, you already know what a queue is, guys. You actually already know what a queue is. These are very well named. A queue is what it is in the real world, in fact. In fact, if you go to a bank, I don't know, actually FNB has them now, right? Like when you click a button at FNB and it gives you that little ticket and it throws you in like a virtual queue and then your ticket number is called. It's the same as like a real queue, except the computer is handling the queue, so you can just sit down. That queue is implemented in a queue, okay? That's how they implemented that queue. It's a data structure. Okay. So what is a queue? A queue is a collection of items and it's no longer homogeneous. So remember, the array was homogeneous. A queue doesn't necessarily have to be homogeneous. So a queue is a collection of items stored in the computer's memory. They are implemented in very different ways across different languages. That doesn't necessarily matter to us. What matters to me is that you understand how they work. And I think the best way to explore this is to just implement one and to show you how much it makes sense, okay? How similar it is to your understanding of a queue from the real world. So the first thing is we're going to create a new queue, okay? We're going to create a queue. And it's easy to create a queue. It's exactly like when we were in chapter 2, when we were creating objects, like if we created a class of type rectangle, we said rectangle, rect1 equals new rectangle, or person, person1 equals new person. This is exactly the same. A queue is just a special class, and we can create it like any other class. So I'm going to delete our arrays there. One special thing, the queue we will be using is in system.collections, not system.collections.generic. So I'm going to say system.collections. We'll explore what this is, like what these imports are doing a bit later on in the course. For now, just understand it's system.collections is what we need. Okay, that's where the queue we are using is. And to create a queue, it's exactly like creating any other object. I'm just going to say queue. The name of my queue, I'm just going to call it queue. Okay, we can call it whatever we want. Even just the letter Q is fine. So QQ equals new queue. Okay, so that creates a queue. Pretty easy. But what is this actually doing? What does that do in the computer's memory? So let's try to visualize it before we work with it. So basically what that did is it created this structure. Okay, again, it's implemented in different ways in different languages and in different, even on different computers, like different architectures. But that's not too relevant to us. What matters is what it's doing, what function it's serving. So what that did is it created this, a bunch of empty space in memory. Okay, a bunch of empty space in memory, and it has a head and a tail. Okay, a head of the queue and the tail of the queue, the head of the queue and the tail of the queue. Okay. And basically, how this works is exactly how a queue works in the real world. We can add items to the queue and we remove them from the queue in a particular order. Okay. What matters a lot about queues, and also the next data structure we'll learn, stacks, is the order, okay? In particular, the order. So there's a couple of commands. So we've discussed this first bit, create. Like as we go through it, we'll be exploring the internal representation. The next idea we wanted to understand is how to use it, right? How do you manipulate the queue? How do we manipulate, like add to the queue and remove from the queue as well, okay? So to manipulate the queue, to add to the queue, we'll use this command .enq. That will add something to the queue. Like it puts it in the queue, enq, okay? So the name of the queue, our queue is called queue, queue.enq, and then the item that you are adding to the queue. So for example, we can add dog to the queue, and that's what it'll do. It'll go to that first place that is currently null. I'll say queue.enq dog, and it's going to change that first place to dog. Okay. So let's go and do that. All right. So I'm going to say queue.enq. I want it to autocomplete so that you can see. So queue.enq dog. Okay. And that's done. So that went ahead and added dog to my queue. All right, it's a queue with one item in it. Obviously, we want something a little bit more interesting. So we're going to add another thing to the queue. So I could say queue.enq5, queue.enq5, and that will add 5 to the queue. Now notice what happened there. Okay, so 5 was added, and you see the tail moved. Okay. We can go ahead and add another thing to our queue. Let's add cat to the queue. So we'll add queue.enq5, queue.enq cat. And you can see that each time I add, what's happening, guys? What is changing when I add something to the queue? Other than obviously it being added itself, what's the important thing to notice about what's changing here? Exactly. The tail follows whatever was most recently added, okay? And remember, the tail obviously is the end of the queue, right? The end of the queue, the last position in the queue, the back of the queue. The tail is the back of the queue. So the back of the queue is what moves, okay? So I'm gonna say .enq5 and then .enq cat. So q.enq5, q.enq cat. Okay, like so. So I've now got that structure in the computer. Okay, so we know how to add to the queue. We use the command enq. That adds to the queue. But we now want to discuss how do we access the queue? How do we actually use the queue? Okay, we now know how to add things to the queue, but we actually want to process the things in the queue. And in particular, there are 2 commands that you need to know here, and then one extra third one that's kind of obvious, okay? But the first 2 are slightly less clear, okay, about the distinction. The first one I want to show you guys is DQ, but actually I'll tell them, yeah. Okay, so DQ. What DQ does is it goes to whatever's at the front of the queue, whatever head is pointing to, okay, the front of the queue, and it DQs it. It removes it from the queue, okay, like so. And it gives it to you, so it returns it. It goes, okay, dog is at the front of the queue, and then it removes dog from the queue, okay? And so if I ran DQ again, it would say 5 is at the front of the queue, and it removes 5 from the queue, okay? However, there is an alternative called peek, okay, peek. So if you peek, then it will show you what's at the front of the queue. So if I say q.peek now, it would say 5 is at the front of the queue, but it won't remove it. Okay? It won't remove it. So DQ will give you what's at the front of the queue and remove it. Peek will just give you what's at the front of the queue. So if you don't want to process the item next, you want to see what the next items from the queue will be. So what the next item you will process will be, but you don't want to process it yet, then we use peek, okay? So let me actually show you this in practice. So we'll say q.enq dog, q.enq5, q.enq cat. So the front of the queue is dog, the back of the queue is cat, okay? We'll actually use it now. So I'll say console.writeLine. Okay. So I'm going to say Q dot peak. And then I'm going to say on the next line as well, just to emphasize the point to you guys, I'm going to say Q dot peak. Okay. Now, from your knowledge of what peak does, what do I expect to happen here? What are the two lines that this will print out? Do think about it, guys. So, okay, so it'll print out. So the first line will print out dog, correct? What will the second line print out? Dog. Exactly. Okay, cool. You've already got it. That's pretty cool. If you don't understand, don't worry. We will still go through. We'll go through a few more different variations of this. So you can see it says dog, dog. Why did it say dog, dog? Because we used peak, right? So peak showed me what was at the front of the queue without processing it. Okay. So dog was at the front of the queue. It showed me that, but at the next stage, it was still at the front of the queue. So let's see what happens if I say DQ. So what will happen now? So I say Q.DQ and then Q.peak. What two lines will this print out now? Anyone know? Feel free to guess a little bit. Trust your instincts. So the difference here, so the distinction of what's happening now is, what this will do now is essentially the example we have here. Okay. So initially we've got dog 5 cat. We run Q.DQ. So that is going to show me dog. It's going to print out dog on that first line. And it's going to remove dog from the queue. And then when I say Q.peak, the new front of the queue is 5. Okay. So let's go check that out. When I run this, it goes dog 5. Okay. Dog 5. If I DQ again, it'll print out the same. It'll actually still go dog 5, right? Because now what it would do is it'd go, okay, dog is the front of the queue, remove it. 5 is the front of the queue, remove it. So previously when I said peak, it didn't remove the 5. Now because I said DQ, it does remove the 5. So if I go to the next line and say console.writeLine, Q.peak, that last line to print out will be cat. Okay. Dog 5 cat. But cat is still in the queue. Okay, because I said peak. If I said DQ, then cat would be removed from the queue as well. Okay. So the difference between DQ and peak is that DQ will process the item and remove it. Peak will just show you the item. It will not remove it from the queue. Okay, will not remove it from the queue. So hopefully you guys understand that distinction. I don't think it's too bad, right? And we'll see it a little bit more with the data structure we'll learn later. There is one more thing that I want to teach you, and then we'll call it there today, because I don't want to stop. I don't want to start learning stacks right before we finish the lecture. But the last command that I want to teach you is q.contains. Okay, so if we have a queue, so currently you guys see we've got like this structure where there's the thing in the front and we can process the thing in the front, right? We can peek at it or we can DQ it. But what if I want to find out if something exists in the queue? And it's a fairly simple command. We won't spend too much time on it. It's .contains. So peek will show me the next item. .contains will tell me whether an item exists in the queue. It won't be processed. Neither of them will process the item. Contains will just show me if it exists. So it'll print out either true or false. Okay. So if I say q.contains 5, right, it'll print out when it eventually runs true. Okay. If I say q.contains cat, it'll print out true. if I say Q dot contains 6? Can you guys tell me what will happen? What if I say Q dot contains 6? What will print out? False, precisely. When it eventually runs. Why? Because 6 is not in the queue, right? 6 is not in the queue, so it's false. All right, so contains will just tell you, doesn't need to be at the front of the queue anymore. Peak will tell you what the next thing will be without processing it. Contains will tell you whether or not something exists in the queue, just true or false, okay? Anywhere in the queue, okay? And that's it. That's all you guys need to know about queues. One thing though, so remember queues, it's about order, okay? If you need a particular order, and how we describe queues is FIFO, or FIFO if you like, but FIFO is the better way to say it. First in, first out. We use queues when we require a FIFO structure, a first in, first out structure. So you can picture at a bank, maybe at some factory lines, wherever you need the first thing to arrive to be the first thing to be processed, we would use a FIFO structure, a first in, first out structure, and that is a queue, okay? First in, first out. Because the first thing we added to the queue, like dog in this case, the first thing we added is the first thing out of the queue, and then 5, and then cat. So the first thing in is the first thing out, FIFO. Okay, so remember that. And yeah, guys, that will be it for today. I don't want to start stacks in the last 6 minutes or last 5 minutes now. We'll go into stacks next week and finish off chapter 3, hopefully. So yeah, guys, thank you for coming. Enjoy your weekends. And yeah, see you guys next week. Cheers, everyone.